Welcome to GChem classes. So today we are going to discuss molecular orbital theory, which yesterday we have left. Right, the video length is like it is going beyond half an hour, so we have to cut short it. And today I am going to continue it. Once this will get over, then tomorrow NEET questionnaires will be there. Okay. So IIT-JAM only I am discussing today. This is a continue part of molecular diagram 2. So we can write it MO02, right? So this is continue. So yesterday we had discussed about homonuclear diatomic molecules. One is left, that is fluorine. I guess you have done that one. So we will do it and then we'll continue to the heteronuclear diatomic and then polyatomic. Correct? After that we will take the questions from previous year JAM. Correct? So F2, for F2, how much it is coming for one fluorine? It will be 1H2, 2H2, 2P5, right? So just have a look. For 2P5 we are going to do it because we know that 1H2 and 2H2 the bond order will be 0, right? So the contribution from 2P5 only it will affect, right? So here one fluorine, this side one fluorine, correct? So we have 2P, here also 2P5. So how many electrons are there? 1, 2, 3, 4, 5. Here also 1, 2, 3, 4, 5, correct? Now we have to create this bonding molecular orbital and anti-bonding molecular orbital, right? So now what will come here? The lowest energy will be for sigma or pi. Comment it. The lower energy, let's see yesterday whatever we have discussed, it is still in your mind or already it's vanished like organic compound, right? Let's see. Okay. Maybe you have answered also. It will be like sigma. Okay, sigma 2p z. Why? Because here sp mixing is not possible because s and p orbitals distance is very much high. The energy gap is very much high. So here sigma 2p z and then this will be sigma. This will be pi 2px pi 2py and then here it will be pi star. I'm not going to write full things. So pi star 2px pi star 2py. Here sigma star 2pz. Okay, so I'll just write sigma. So how many electrons are there? 5, 5, 10. Okay, that you have to fill it up here. So how much? 1, 2, then 3, 4, 5, 6, 7, 8, 9, 10. So 10 electrons you have filled. Now bond order. How much? What is the bond order here? Bond order. Number of electron in bonding. So how many are there? 6 minus number of electrons in anti-bonding. How many are there? 4 divided by 2. It will be like 2 by 2, 1. So in between fluorine and fluorine only one bond is there. And this bond is sigma bond or pi bond? Just tell me whether this bond is sigma or pi. How you are going to calculate? Simply 1 sigma pi 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 pi. These are pi star. Okay. So now how you are going to calculate it in mathematical way? It will be like total number of bonds. How many are there? Just bonding minus anti-bonding you do it. Okay. So we have 1 sigma and plus how many pi are there? 2 pi are there, right? 2 pi bonds minus this will be overall, right? Minus how many sigma bond? 0 sigma bond because in sigma star nothing is there. Plus how many pi bonds are there? 2 pi bonds are there. Okay. So what will happen here? This 2 pi and this 2 pi will cancel it out. So here it will be 0 and this sigma and 0. So it will be 1 sigma. So there is 1 sigma bond only, right? So what is the nature of this bond? This bond's nature is sigma bond. Correct. This bond nature is sigma bond because it is from sigma 2pz. So this is for fluorine, right? And what is the magnetic properties of this fluorine? It's a diamagnetic, right? Where everything is paired up. There is no unpaired electron. So it will be a diamagnetic. Correct. So next we will now the homonuclear diatomic is completed here. The next it will be we will have heteronuclear diatomic, right? So let's see, 1 or 2 I will discuss and then remaining I will discuss it from your question. They have asked very nice questions in previous years, right? So we are expecting the same nice questions from the upcoming examination, correct? So next will be heteronuclear diatomic molecule. I'll take HF. Here so many things you have to put it in your mind, while drawing this MO, there are some conditions you just keep it in mind. First you just write it down. For hydrogen it will be 1s1 and for fluorine also you write it it will be 1s2, 2s2, 2p5. Now you see the last one will contribute, right? And one more thing is that the electronegativity difference. Here you will come to know the bond nature of HF, how the bond nature is taking, like how you are going to say that the paired electron pair are like the bonding pair electrons are towards the fluorine because of electronegativity. Here you can see it, right? So now I'll just draw it. This is hydrogen, this is fluorine, and fluorine is more electronegative. So the more electronegative orbital will be in the lower energy side, right? The more electronegative elements, atomic orbitals will be in lower side. This will be fluorine's 2s and this will be fluorine's 2p, correct? And this is electropositive, so it will be in upper side, 1s, correct? So we have one electron here, we have 1, 2, 3, 4, 5 electron here. Here we have 2 electron. So the energy gap, see from here to here, the energy gap is more. So this won't be participated in orbital overlap. So what will happen? This will, as it is, it will present as a lone pair, correct? Now the next thing, what will happen? So this one sigma bond it will form, okay? Okay, one sigma bond will be there. So sigma, and then it will be this one electron and this one electron will make one bond, correct? And then remaining will be like as a non-bonding electron, this one and this one. These two are NB, NB, non-bonding electrons, right? Now similarly we will have one anti-bonding also. This will be sigma star. Now there are so many things in this, okay, which you have to understand. First we will just calculate the bond order, okay, then we will see. Bond order will be number of electron in bonding, not the non-bonding and non-bonding, okay? This is also non-bonding. The bonding, how many electrons are there? 2. So don't calculate it like 2 all together 8 minus 0, don't do that. Only bonding, this is BMO, right? Bonding molecular orbital, and these are the non-bonding. So you have to calculate here number of electron in bonding is 2 minus how many electrons there in anti-bonding? 0 electrons, right? So put it 0 divided by 2. So how much it is coming? 1. So in between hydrogen and fluorine, what is the bond order? 1. So there will be one bond, right? Hydrogen, in between hydrogen and fluorine, correct? And one more thing, whether this is sigma bond or pi bond, this is sigma bond, right? In this sigma, this we are calculating. So this one thing, this is sigma bond, and what all we can get it from here. This is a diamagnetic or paramagnetic. This is a diamagnetic, correct? What else? Tell me, what else we will come to know? Now, just see, hydrogen and fluorine. This we call more electronegative, this is electropositive, right? And we say that whatever the sharing of electron has happened, both the electron will be towards fluorine, right? That we are saying always, that whenever this bond will break, this fluorine will take those electrons. Here you can see this MO diagram will explain you. See, this fluorine's molecular orbital, bonding molecular orbital is here, and here is orbital where the participation, okay? So this distance will be, the energy gap is minimum, and here you say just extend it from here to here. See the energy gap, this is maximum, right? So you will see that BMO, that bonding molecular orbital is nearer to fluorine site, right? Whatever the bonding pair of electron is there, that is nearby fluorine. This MO is explaining to you, right? See, the bonding molecular orbitals electrons are nearer to fluorine's orbital, correct? And you just see the anti-bonding molecular orbital, you just extend it from here to here. See, the energy gap is less, so it means the anti-bonding molecular orbital is nearer to hydrogen, but it is far away from your fluorine atomic orbitals. There are so many things you can bring out from this MO diagram, right? That's why the advanced and latest theory is MO theory, okay, molecular orbital theory. So now you come to know that why this electron pair towards fluorine and why this fluorine is attracting both the electrons wherever this bond is breaking, right? So here also HOMO and like HOMO and LUMO you can calculate this. That you only comment it, okay? What is HOMO for this? I'm not going to write it. HOMO and LUMO. These two you just comment it, okay? These are very simple things. So now for HF, now we will take it polyatomic, okay? There are so many. NO is there. You just try it for NO. Okay, this one. You can try it. Okay, it is not means that no, it is nitrogen and oxygen. Okay, so I'm rubbing the board. We'll take polyatomic. Okay, we will take polyatomic now. You just try it by yourself for this molecule NO. Okay, so nuclear diatomic, we will take it. For first example, we'll take it H2O. Okay, we'll take it H2O. Okay, so in this also, what we are going to write it. So just draw it. Oxygen will be this side, hydrogen will be this side. For hydrogen, it will be 1s1. Always do this exercise. For two hydrogen. For oxygen, it will be 1s2, 2s2, 2p4. Your picture should be clear here. Okay, whatever you are going to write it here. So these two we are not going to do it. Only like 1s1 and 1s2. For this 1s2, I am not going to take it because the energy gap will be it will be more, right? So now hydrogen, it will be here, somewhere here. Okay, and for oxygen, the 2p will be here down and 2s will be further down, right? So there are two hydrogens, so we have to take similarly two hydrogen, right? Two hydrogens orbitals, right? Now what is happening here? It will be 2s2, here it will be 2p4. So these two, and we know that it will be in non-bonding because the energy gap is more. So the overlapping will not take place. Now for P, what is happening? This will be sigma. Okay, P just we'll write it down. 1, 2, 3, 4. This will be sigma 1. Okay, here 1 electron, and for this orbital 1 electron is there. So 1, 2. Okay, 1 electron came. One more sigma will be there. This is sigma 2. Here also 1 electron. And this second hydrogen's 1 electron will come, and then we will have one non-bonding, correct? Similarly, 1 sigma star, another sigma star, right? So this will be your sigma 1 star, this will be your sigma 2 star, correct? Now in this again you can see it, the bonding molecular orbital is nearer to oxygen because wherever the bond will break, hydrogen will be as a H plus and O will be OH minus, right? So here what is happening, just calculate the bond order first and then remaining we will see. Number of electron in bonding molecular orbital is 4 minus anti-bonding, nothing is there, 0 divided by 2. So how much it is coming? 4 by 2 means 2, right? So this bond order is 2. So we can write HOH bond order is 2. So each, this we have to write, each OH bond order will be 2 by 2. So it will be 1 because this is for together, right? OH 2. So this 1 is whether it's a sigma bond or pi bond. Like both the like bond you have to calculate whether it's a sigma bond or pi bond. So see the nature, it is a sigma, it is in sigma. So both the bonds are 2 sigma bonds. Okay, both the bonds are sigma. So here also LUMO and HOMO you have to calculate it. You just do that. What else we will come to know here? Like this is a polyatomic, right? Both the hydrogen you have to take it together, and then this oxygen, then overlap will happen. So whatever molecule is there, you can easily do it by yourself, right? Now the MO theory is, I think, almost it is clear. So I think we can take the questions, right? Okay, we will take the questions from previous years. Okay, this is also it was like diatomic, right? H2O is diatomic, not diamagnetic, not paramagnetic, correct? Because all the electrons were in paired form. We'll take the questions. So the first question from 2022. Okay, the question number is 39. It has asked for MO theory. The conversion of ICl to ICl plus involves. Okay, they are asking that ICl to ICl plus. Okay, ICl to ICl plus, and there are, you can see in the screen the options. Okay, that they are saying that first the removal of an electron from a pi star molecular orbital of ICl. We are not going to discuss this option right now. Just we will draw it MO diagram for this. Everything will be clear, right? If you are able to draw the MO diagram, everything will be clearer. So in this iodine and chlorine, which one will have more kind of like electronegative? Which one is have electronegativity more? Just tell me. chlorine will have, okay, because from top to bottom if we are going, then electronegativity will decrease, right? So what we are going to do it, we'll just do for chlorine and iodine. So just first we will write it 1s, like we are not going to write 1s2, outer is enough, okay. So how you will come to know where it will come? Fluorine, chlorine, bromine, iodine. So this will be 2p, 3p, 4p, 5p. So just write 5p, 5, and for chlorine you just write 2p, 3p, 3p, 5. Okay. So now we are going to do it. MO diagram, we are just going to write it. Chlorine, for chlorine it will be like more electronegative, so it will bring down. So we'll take chlorine this side, we'll take iodine this side. So this will be for chlorine. Okay. How much? 5. 1, 2, 2, 3, 4, 5. And here I'll take it for iodine. 1, 2, 3, 4, 5. Okay. Now what we have to do it? This is similar to fluorine, but there will be atomic orbitals, energy gap will be there because more electronegative and lesser electronegative. But in fluorine atom, that were homonuclear diatomic, no? So both the fluorine will have equal electronegativity. So that's why they were in same energy level, right? But in this case, one is iodine, one is chlorine. So there will be electronegativity difference, and based on electronegativity difference, one will be in lesser energy side and one atomic orbitals will be in higher energy side, correct? Now what we have to do it, first we will see the sigma. This will be sigma, and then pi, then pi star, then sigma star. Okay, so sigma, this is sigma star, these two are pi, these are pi star. Okay, just we are going to fill it up. 5, 5, 10 electrons are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 electrons we have filled, right? So bond order, whether we are going to calculate bond order or we'll go to the options. Just we'll go to the options and we'll see. The first option is the removal of an electron from a pi star molecular orbital of ICL. So ICL to ICL plus we are going. So which electron will be removed? So outer electron will be removed. So this electron will go out. If this electron is going out, then it will be from pi star it is going, right? From pi star it is going. So option A is correct. I'll just write C and D. Option A is correct because it is removing from pi star itself, right? An increase in the bond order from 1 in ICL to 1.5 in ICL plus, that we have to calculate, right? So bond order we have to calculate. Bond order for this ICL all together, it will be like 6 minus 4. So 6 minus 4 divided by 2, it will be 2 by 2, it will be 1. And after removing 1 electron, what will be the bond order? I'll just star mark, I'll do star mark here. Bond order equal to 6 minus 1 electron if it is going from here, then remaining will be 3. So 3 by 2, it is 1.5, right? So what is that option? An increase in the bond order from 1 in ICL to 1.5 in ICL plus. It's correct, right? From 1 to 1.5 it is going. So option B is also correct. Now coming to the option C, the formation of a paramagnetic species. The formation of a paramagnetic species. Okay, means the question is itself is coming ICL to ICL plus. So when ICL to ICL plus is taking place, obviously before that it was diamagnetic, right? For ICL it is diamagnetic. 1 electron if you are removing, it is paramagnetic, right? So this option is also correct because it is paramagnetic. Then next question, the removal of an electron from a molecular orbital localized predominantly on chlorine, right? The removal of an electron from a molecular orbital localized predominantly on chlorine. See, this electron is not belongs from chlorine molecular orbital, right? This is now they have shared, correct? So individually you can't say it is going from chlorine because it is not going from here, right? This is atomic orbital. If any electron is going from here, then you can say that it is from chlorine, right? This is MO diagram for both chlorine and fluorine, right? So this option, like option D, is not correct. So this will be not correct. So your correct option will be A, B, C. Correct? I think I am correct. So everything. So question number 39, so A, B, C, these three will be correct. Okay. So next question we will take it. Next question we will take it. It's very simple. Here only we can write it. Question number 45, NET type. Okay. This was MSQ. This is NET. Bond order they are asking for B2. I'm not going to solve it. You just solve it for boron. Okay. You know that each boron it will be 1s2, 2s2, 2p1. So this you just left it. This 2p1 you just draw it. Okay. Okay, this is 2p1, 2p1, and then this down what will happen? Pi, this is sigma. Okay, likewise you calculate, this is pi, this, because sp mixing is happening, no? So 1 1 1 or 1 2. So bond order will be 2 minus 0 by 2 barabar 1. So bond order will be 1. They have asked only bond order. They should ask the nature of bond, whether it's a pi or sigma, right? So your answer is 1 here, right? So this is all about 2022, I guess. Now directly we'll go to 2019. There are many questions in 2019, right? So I'll rub the board. I think you are enjoying, right? If you are enjoying, then it is well and good. If you are not enjoying, then again you will search one more video from one other classes, right? Other coaching institute, whether they are, how they are teaching molecular orbital. Okay, I guess many are there who is teaching, but I'm just taking those concepts which are your like for this upcoming examination, whatever is requirement, like these questions easily you can solve it. So that's why I'm taking up this question. So now the question number 5 from 2019 JAM. Okay, question number 5. What they are asking, correct trend in bond order is, so O2 plus and then O2 2 minus and then O2 minus. Just you solve it. For what you have to do it, first you have to draw bond order of like MO diagram for oxygen. Then only everything will be done. So for oxygen, what is the electron configuration? 1s2, 2s2, 2p4. One bond or like one molecular diagram is enough to explain everything, right? So 1 2 3 4, here also 1 2 3 4, and now what you have to do it, oxygen, there won't be sp mixing, so pz will be in down, sigma, this is pi, these are pi. See, do practice, it will be very much easy. Don't find shortcuts. Okay, shortcuts will lead you in a trap. Correct? So now sigma, this is pi, this is also pi star, this is sigma star. Now just start filling. 4 and 4, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is showing diamagnetic. They are not asking, just they are asking the trends, following the trends based on bond order. Okay. So bond order, we have to find it out. First we will take it for plus. So one electron we are removing. Okay. So bond order of O2 plus. If one electron we are removing from antibonding, it will go from antibonding itself. So it will be like 6 minus 1. Okay, so 5 by 2. So it will come in 2.5. So just I'll write it down. 6 minus 1, because 1 already we have removed, because O2 plus divided by 2, it will be 2.5, right? Now bond order of O2 2 minus, because 2 minus means 2 electron we are adding up. 1 electron, 2 electron we are adding up, right? So it will be 6 minus 4. So how much it is coming? 6 minus 4, 2 by 2, it will be 1. And what about bond order of O2 minus? O2 minus means only 1 electron we are adding up. So 6 minus 3. Right? So 6 minus 3 divided by 2, it will be 3 by 2, 1.5. So bond order trends, you can just write it down. First will be O2 plus, then your O2 minus, then O2 2 minus, and based on option you just correct it. I think option O2 plus, then O2 2 minus, no, O2 plus, then O2 minus, and O2 2 minus. Option D, okay, option D is correct. And likewise you just solve it. Wherever you will find questions regarding bond order, molecular orbital, just first job is to draw this molecular diagram, okay, and then only you solve it. Otherwise it will be like you are making complicated. Okay, so next question we will take it from same year in 2019. There are so many questions they have asked. So next question will be, just next question we'll see. They are asking the correct statement regarding the observed magnetic properties of, see now NO has came, you have already done, right? O2, B2 and C2 in their ground studies. So NO, O2, B2 and C2, they are asking the magnetic properties. Okay, try to do it. Okay. Okay. So how you are going to do this? O2, B2, C2, already you know it, right? Based on that you just take it. For NO you draw it. So nitrogen, how much it is coming? 1H2, 2H2, 2P3. Oxygen, how much it is coming? 1H2, 2H2, 2P4. So these things is not required. So which one will have more electronegative, nitrogen or oxygen? Oxygen will have more electronegative. So here it will be down. For nitrogen it will be here. So how many electrons are there? 1, 2, 3, 4. Here 1, 2, 3. Correct. So now how the molecular orbital you are going to bonding molecular orbital you are framing. See, first it will be sigma. Correct. And then pi. Then pi star. Whatever is required, just make it and then you start filling. This is pi star, and this is sigma star. Now 3 and 4. Okay, so one thing you just see, for oxygen we don't have 3d, right? Like d orbital we don't have. So this electron will not participate in making bond because in each orbital there should be maximum 2 electron, right? And already it is having. It's having. So how the bond will form now? So 2 electron here, 2 electron. We'll take it first 1, okay, and then 2, okay. Then here it will be your third one, but this will be alone. This is not making any bond with anyone, right? So what will happen? So this together it will come here as a lone pair, but the thing is like you have seen, no, that nitrogen, if having lone pair, it will give the hydrogen, and this bond nature will be nitrogen will having positive, right? Why? Because this hydrogen, it will act as a H plus. If H plus is coming, nitrogen's lone pair will attract this one. So it's a similar way. This oxygen is what this oxygen is doing. It is just giving like this. This bond nature will be like this, and to an oxygen. Now oxygen's lone pair will give one bond like this, okay. So likewise this bond will form. So this lone pair is participating in bond making, but together it is contributing to nitrogen, correct? So this type of bond, and here it won't be bond order 3, just we are going to calculate it, and you see bond order won't be 3, it will be somewhere 2.5 or 2.6, 2.8, something it will come. So now you just see how many are there, just you fill it up. 1, 2, 3, 4, 5, 6, 7, okay. So 2, 2, 2, so how much? 6, and 1 will be here 7, right? So what will be the bond order? Don't get confused, okay? It is in detail, okay? It is required for CSIR. Don't go that much far away. Be here. You have to just calculate, right? Magnetic properties. So we are going to do it. So it will be like 6 minus 1 divided by 2. So it will be 5 by 2. 2.5. See, bond order is 2.5, not 3. So the bond nature you have just understood. It will be this kind of thing, right? Bond order is 2.5. And you have to calculate the magnetic properties, right? So this is single paired, unpaired electron, so it is paramagnetic. Okay, paramagnetic. For oxygen, just we will frame it here only. Oxygen, both the side 4 electrons are there, and oxygen we know that mixing won't be taking place. We will just write it like this. So 4 and 4, 8. 1, 2, 3, 4, 5, 6, 7, 8. Unpaired electron is there. So this is also paramagnetic for O2. Okay, and then we will, here only we will do it for B2. Just B2 we will write it. This is also paramagnetic, no? NO is also paramagnetic. So B2, for B2 it will be like 1 electron and 1 electron. P1, right? So it will be 1. It will be 1. Like this. So 1, 2. So here also unpaired electron. So B2 is also paramagnetic. And then C2. Okay, 2P2, right? So you can write it 1, 2, 1, 2. Now you just see it. Carbon, it will be mixing will be there. Okay, sp mixing will be there. So 1, 2, 3, 1, 2, 3. So it will be like 1, 2, 3, 4. So what is happening here? Here it will be diamagnetic. So remaining all are para, only is one is dia. Okay, NO, B2 and C2 are paramagnetic. B2, O2 and NO are paramagnetic. B2, O2 and NO are paramagnetic. Correct. Option B will be correct option for you. Option B will be correct option. Correct. So option B is correct option. Okay, this will be diamagnetic. Carbon will be diamagnetic. Next question, what they have asked. Let's draw it. Okay, bond order of N2 plus. Just draw the bond order for like MO diagram for N2 and then remove one electron from anti-bonding. If it is there in anti-bonding, you just remove it. If it is there in bonding, you just remove it. Likewise, you solve this one, and this question you try to solve. Okay, and if any other questions are there, you just take it and solve it. Okay, so these are the questions which previously PYQ, from PYQ we have taken. So is there any further questions are there for MO diagram? You can directly WhatsApp me and you can ask me. Okay, so thank you very much for watching.